Hello and welcome, everyone. I'm Jim Olson, Assistant Executive Director of the NTCA, and thank you for attending today. Today's webinar is titled Large Format Tile and Stone. It's information on proper surface preparation, current installation standards for LFT, soft joint placement, and products used to ensure a successful installation. Our sponsor for this presentation is Custom Building Products. Before we continue, I do have some business to take care of. First, this program is AIA accredited for 1 hour of CEU. Please check the chat screen for Andrew's contact information. I'll put his email on there for you, and you can email him and he will get your CEU to you. All right, so look for that on the chat screen. Today's webinar will be muted. Please use the questions area of your computer to type in your questions. We will answer your questions at the end of this presentation. All of our webinars are archived and available to watch at any time after the webinars are presented. I will provide my email address on the chat screen, and please email your requests to me after the program has finished. If the audio on your computer is poor, call the number on your invite to this webinar and listen on your phone. All right, here we go. Today's speaker, Andrew Ferraiuolo, is the Northeastern U.S. Commercial Architectural Representative with Custom Building Products. Andrew worked as a contractor for 15 years and has spent the last 10 years working directly with the architectural and design community to provide assistance with information on the constantly changing surface prep, tile installation products, and standards. Welcome, Andrew.
Well, thank you, Jim. Happy to be here.
Thank you.
Okay, so first I want to start off by thanking you, Jim, and the NTCA. We really appreciate this opportunity. All of Custom does. We're excited to do these whenever we have that opportunity, and you give it to us, so thank you very much. Today's presentation, as Jim said, is on large format tile and stone installation. I work with architects and designers and specifiers, typically, contractors at job sites as well. So some of this is going to cover everything along that line, and Jim outlined the presentation very well there. So let's get right into it. This is AIA accredited, of course. Some of the objectives of what we're going to be looking at today is what exactly is large format tile and stone. The importance of surface preparation. Now, surface preparation is always important with flooring products, but of course that ramps up a little bit with large format tile, so we'll cover it. Specifying a membrane. What are the common membranes that are out there now, like waterproofing and crack isolation membranes? Installation products for the LFT, how do they change? What type of mortars are being used? Expansion and control joints. Number one reason tile installations fail, I'm told, is improper expansion and lack of expansion and control joints. And language for specifications. This is an important subject for designers, architects, and contractors as well, to know what you're looking for and what you want to see in those documents. So first we have to start with the TCNA and the ANSI catalog. TCNA is the Tile Council of North America on the left, and on the right, the ANSI, American National Standards Institute catalog. The industry is actually very lucky, tile industry. Other industries don't have these type of catalogs and workbooks to go by. They don't have the format and the guidance that these books offer. You'll hear me refer to these books quite a bit during the presentation. If you don't have one in your office, it's an important addition if you're a tile installer or an architect designer, because of everything that's inside there as far as installation methods, specifications for the products, as well as the installation specifications. We're going to take a look at the first page here of what we see typically in ANSI. The ANSI Catalog 108 section is the installation standards for tile setting materials. So if you were talking about a grout and how that grout is installed and some of the standards for installation, like temperature or setting time, you would look in the A108 section of ANSI and you would be offered support there for that topic. ANSI 118 is the standards for the products themselves. So what makes up the grout? What are the components, the performance characteristics? If I say a grout meets an ANSI 118.7, which is a cement grout standard, you'll know that that grout meets all those standards that go with that classification, including the ASTMs for flexural strength, bonding, freeze thaw, compression or PSI. So those things are built in when you say a grout meets that standard. And that is, of course, obviously found in the ANSI catalog. The 136 standard, about the middle of the page here we're looking, is organic adhesives, what we know traditionally as mastics in the industry. 1371 is for ceramic tile, which would include your porcelains, of course. 1372 glass tile, and 138 is the green squares sustainability. That's the globally responsible standard for sustainability in the tile industry. Now, these standards do change from time to time. There's additions to them, and that's kind of why it's important to make sure that your catalog is up to date. If you notice, we go back to the TCNA book, it says 2019 on the bottom, on the left side there, the right corner. These books are produced every year now. And some years have subtle changes, and then some years have large changes. So it's good to keep up to date on these catalogs because of the changes that happen. And here we have in the next slide some recent changes, some new additions. So in the ANSI catalog, the 108.19 addresses the gauge porcelain. This is the thin porcelain panels and slabs, and we're going to take a look at them a little closer going forward. But this addresses the installation standards for those products, as well as the 137.3, which is the specifications for the tile itself. As far as, like I say, the manufacturing the tile and the standards it needs to meet that 137.3. So when you're looking for a gauge porcelain, we would suggest you make sure it meets the A137.3. That's how this is used. Okay, what is large format tile? Large format tile is any tile with at least one dimensional side 15 inches or larger. Right, I twisted that around, 15 inches or larger dimensional side. So as per ANSI, that's the classification of the large format tile. 15 inches or larger on one side. So that would mean a 15 by 3 or a 16 by 3 or 16 by 6 would all meet that classification of large format tile. And there's things that change as far as installation and surface prep when we get to that classification large format. And obviously we're going to talk about that. It wasn't long ago that 8 and 12 inch were the most common tile we would see, but that's changed quite a bit. We don't really see that many 4x4, 8x8s except in utility areas, or maybe they're designed into the project for a specific look. A lot of times it's 24 by 24 or 36 by 24, and even up to 48 inches are very common on projects now. That gauge porcelain I was talking to, it could be up to 10 feet and range in thickness. And that's exactly what gauged means, the thickness, and we're going to talk about that. So you see an application here with large format tile, these tile on the floor. They're narrower, they're plank tile. They may have a wood look, they may have a stone look, but they're classified as large format tile. Just taking a look at some pictures of some uses. You see they're eliminating a lot of grout joints here. This is a design consideration. And you'll see the style and color. It's all over the place now. You can get anything. You can get a stone looking tile. You can get a metal looking tile in the large format and gauged porcelain. Here we see a gauged porcelain on the table, and they're using what some call a glazer's rack, something you would use to move glass to move this tile. 118 inch long tile, that's about 9.5 feet, I believe, if I'm doing that right. And you see them moving it here. This tile, if they were to pick it up, it would be very difficult to handle. They may break under its own weight. So they use the glazer's rack, the same reason that glass installers use it to move the product around. Here you have them pressing the tile into the mortar that was attached to it, that was already installed on the wall. There's 3 people doing this because it's our training facility, but usually 2 people could definitely do this, pressing it in, and you see them rolling it in here. And you see they cut the outlets just like you would a wallboard or a sheetrock. Now these are being used, and of course designers and architects, very, very creative uses for these products. They're being used all over already. Here you see it being installed. We're looking at this picture here, and you can see them on the floor, and you can see the black stripe running through them. And then here's a picture from the job when it was going on, and they were cutting that stripe into the large panels. Obviously that has a marble look. That's not real marble. That's a porcelain tile. And once it's polished up, cleaned up, and the project is completed, you see the look that they achieved with those panels. Minimal grout joints. But not all large format tile are gauged porcelain. The large panels we talk about, and these are maybe 24 by 24, 24 by 36. And we even see the dark tile here, which would be maybe a 4 by 24. And that's considered a large format tile. Let's start at the start, the substrate, right? The substrate is always important for any finished flooring, but certainly as the tiles become larger, it has become even more critical. So ANSI 108.01, the standard for preparation of a substrate, says that the substrate must be sound. Certainly, we don't want that breaking down or chipping or spalling. It must be true and smooth, which would not necessarily mean level, because we may not want it level. We may need a pitch for some reason, pitching to a drain, but very flat. Ready to accept bonding materials. This is extremely important because the mortar does do exactly that. Cement-based mortars, Portland cement-based mortars, they'll bond to a concrete substrate with adhesion, absolutely, but also by growing into that concrete a bit, providing a mechanical bond. So those concrete substrates in particular need to be ready to accept that bonding material, meaning they need to be porous enough for the mortar to grow in, but not too porous. Too high of a porosity level will make the moisture, the water in the mortar, drain into the concrete or be pulled out of the mortar into the concrete and change the bond strength of that mortar. So not too high of a porosity, but certainly we need porosity in the concrete. Take a look at another situation. This is a very, very simplified drawing. And this is, by the way, this is the extent of what I know about engineering, of what I was told here. A word on deflection. So what deflection is how much that wall or substrate floor is going to move and what's allowable for a tile installation. Now, these standards are set by the IRC, which is the IBC, International Building Code, and the IRC, International Residential Code. And traditionally, we'll hear L over 360. We need L over 360 as far as deflection. Now, keep in mind that your local or regional codes may have a more strict tolerance than that, and you need to be aware of that and go by that. But if we just take L over 360 as an example to see what deflection is, we can see that L is the length on the top drawing. Okay, and then we move down to the middle section where it says the maximal allowable is L over 360. So down to the word deflection, looking across, we have the L over 360. Well, we have to put the footage in, which is 20 feet. We have to turn that footage into inches. So we do 20 by 12, and we end up at 240 inches. And then we do the calculation, which is roughly the 0.666. And then the 5/8 of an inch. So the deflection for that area is going to be in the 5/8 of an inch range. And again, this is not meant to be accurate for any particular project, just to show how deflection works and to be aware of the L over 360 and how that's needed on job sites. Now you need to make considerations. Again, this is oversimplified for live load, dead load, impact load, and the stone setting materials, the weight of the materials themselves that are going to be make up the flooring product. On the right, you'll see for stone, the National Stone Institute, which used to be the MIA, by the way, used to be the Marble Industry Institute of America, rather. It's now the NSI, the Natural Stone Institute, suggests L over 720 for stone. So it's double the standard as far as the, how strict the movement can be. And there's a lot of reasons for that. The stone is heavier, certainly more brittle than tile. So that's what the recommendation is, and that's what we suggest whenever asked. Again, this is simplified, but this is exactly how deflection is calculated and works. Okay, large format tile, as we said, 15 inches. For tile with at least one edge, 15-inch maximum, the allowable variation in a floor is 1/8 in 10. So in a floor, you could have 1/8 a dip or a bump above your finished grade that you need in that flooring. 1/8 above or below is acceptable in any 10-foot area. If it's deeper or higher than that, then the floor has to be treated with either maybe grinding for high bumps or filling for low bumps. And also no more than a 16th in a 24-inch. Now that's for large format tile, as it says there, 15 inches or larger. Traditional tile, and what the standard has always been in the past before these large format took over, is 1/4 in 10, the next paragraph down. So any tile that is smaller than 15 inches still goes by that guideline of 1/4 in 10 with no more than a 16th in 12. There's a lot of ways that we get there. It would be, what are we going to do to the floor? We'll take a look at that next to reach those standards. By the way, any stone is an 1/8 in 10, regardless of the size. This comes right out of TCNA. Any size stone should be an 1/8 in 10, the top standard, the more strict standard for stone tile. And that is regardless of the size. So how are we going to do that? How are we going to treat this floor and get it to the point where it's suitable for our tile installation? On the left, you see them patching. Of course, you could patch a low area. There are a lot of patching products on the market. What I would say about that is make sure that the patching product that you're either specifying or using is not the mortar. There are specific products made for patching. The reason is they bond differently, they have moisture resistance differently, they shrink or don't shrink differently than a bonding mortar. So always use a product that's made for that application. You could also create a mud bed if you have the height capability or if you have the weight capability. You can see it's obviously, this is what's called a cleavage membrane mud bed, which is a pretty deep mud bed with fiber reinforcing in the middle. It's an unbonded mud bed. It has a plastic underneath it to keep it from bonding to the substrate. It's just one type of mud bed, the type of mud bed we would use above grade, but it's an example of a mud bed. If you have like I say, the depth and the weight to do it, you can level a floor this way. The other way, and what's become really common nowadays, in fact, used to be specialized contractors did this, and they still do, of course, but tile installers are now getting into this in smaller projects and actually medium-sized projects. It's self-leveling. So a self-leveling product could be mixed and poured onto a substrate, and you'll see the gentleman on the left here in the orange shirt is pouring. This is called barrel mixing. So he's mixing that on site by the bag and then dumping it out. The gentleman on the right, he's going to make sure that product moves as it should to self-level, and it'll do exactly that. It'll self-level, find its height. Now, if you have a doorway or a door jamb, it could be dammed up with something to keep the product from flowing out into the opening. And you see the finished result below. So if we have a large format tile and we need that 1/8 in 10, and it's going to be cumbersome to patch and grind and do all that, you could self-level the area. It's much more efficient for large areas. Again, this is one of the topics that is in this presentation that's really a topic on its own, but we're bringing it up, and I could always provide more information further on down the line if you need information on this. Same thing with this, moisture and concrete. I'm just going to touch on it because it's something to be aware of in any size tile, but certainly when you're talking about large format tile and self-leveling, this is something that's really big right now, awareness-wise with the flooring that's being done. ASTM 1869 on the left side. Now that's the calcium chloride test. That'll test how much moisture is being emitted from your concrete slab. That affects the flooring product, whether it's a luxury vinyl, a carpet, a tile. The test on the right is the probe test, which is the ASTM F2170. That's going to be the future. That tells you how much moisture is in the slab and how much is going to come out of the slab. So these are two tests that are conducted on job sites to find out the moisture in the concrete and what the situation is, because each flooring product, whether it's carpet, whether it's a vinyl, resilient tile, they all have their standards they need to meet as far as moisture vapor control. And so these are two ways that that's tested for. And then this is the mitigation process. Again, we're not going to spend too much time on this, but just be aware that these products exist on the market. They're two-part epoxy. They go down in a very high relative humidity, and they will perm over a certain amount of time, but they'll control the permeance of that concrete so it won't affect the flooring above. You'll see in this case it's a color so that they see where it's being spread. So they'll install the moisture mitigation onto a concrete substrate that's not suitable for flooring. It's just the vapor is too high, or possibly they don't have time to worry about that. They want to make sure that they just, they're on fast track. So instead of testing the concrete or helping the concrete will dry out, they're going to go ahead and moisture mitigate, they're going to self-level, and they're going to install the flooring. Again, another topic we could talk quite a bit offline about. So my joke for the day, there's two types of concrete, cracked and gonna crack. So we have provisions for that, of course, in the manufacturing world. Crack isolation and waterproof membranes. Now, crack isolation or anti-fracture, you'll hear those two terms. They're really synonymous with each other. They're really the same thing. Maybe manufacturers at one time would use them. It's tomato. It's crack isolation membrane. ANSI has a standard for those products. You'll see it on the top there. It's the ANSI A11812. So if you have a crack isolation membrane on a project, I would say that, or suggest that you certainly want to make sure it meets the ANSI 11812 standard. In that standard are, again, the ASTMs that govern the movement and the bonding and things like that of that membrane. So you're covered when you have that. And for the specifiers, when you have a submittal come in and you have called out an ANSI 11812 in your specification or your design, when you have a submittal come in for another manufacturer's product, it's an easy way to see if that other manufacturer's product meets the same standards as the product you called. On a tech data sheet, it will list whether it meets the ANSI A11812, or maybe the setting materials manufacturer, the professional that works there, will offer that information to you. So you can see if it's apples to apples. And that goes for all those tile installation products that have an ANSI standard. It's really a big help as far as keeping the playing field level and apples to apples as far as performance of the products. So what does a crack isolation membrane do? It's going to protect the tile from the minor movement, and it's the in-plane movement. We consider in-plane movement, we'll say side to side. It's not going to protect the flooring above if the concrete is not side to side. Let's say that it's raising up on one side of a crack, or dropping on one side of the crack, which is the same effect. That's up and down. That's not in-plane movement, and these membranes are not designed to handle that type of movement. They're designed to handle the in-plane. And when we say minor, the standard is 1/8 of movement. So the ANSI standard for 11812 is to be able to handle 1/8 of movement of the substrate. Waterproofing membrane, the ANSI standard is 11810. Now, what we expect out of a waterproof membrane is to block bulk water from passing through it. So we're talking about in showers, in bathroom situations, in water features, whether it be a fountain, in pools, areas like this, exterior, where you would use a waterproof membrane. They'll reduce efflorescence, and the way they do that is they don't allow the bulk water to pass through the tile installation into the substrate, and then as it dries, for that to pass back up through the flooring in vapor. It'll pull all the efflorescence from that concrete back up through the tile, through the grout, and waterproof membrane doesn't allow that because it doesn't allow the water, the bulk water, to get to the concrete in the first place. It'll obviously help protect the space below in a bathroom area. We see a lot of commercial installations where they use the waterproof membrane throughout the bathroom area, not just in the showers, for that exact reason, or maybe in high-rise or multi-residential. There's tremendous savings in keeping that water inside of that bathroom as far as damage to the spaces below. If we take a look at the installation of the I have something froze here. Hang on one second. Oh, there we go. If you take a look at the installation, this happens to be a liquid applied crack isolation membrane, and it has the dual purpose of being a waterproofer as well. And that's why we kind of highlight it in this presentation. These liquid applied crack isolation membranes also offer waterproofing and vice versa. So if you needed a waterproofing in an area, which I would say is the situation in this picture, because you can see where the drains would be, or possibly the toilets here on the right side. This would be a waterproof basic installation, but they're also getting crack isolation membrane because this is a dual purpose product. Now, all the manufacturers who make these type of products make them in a color. They'll come in, this particular one comes in a pink, and once it's rolled on and it dries, it tells the contractor it's dry by turning dark red. And then they know it's ready for the second coat. There's other manufacturers who go on light green and they'll turn to a dark green, light blue, they'll turn to a dark blue, and work the same way. And these dry very rapid. I mean, depending on the relative humidity, of course, but typically we say about 2 hours per coat. And that's why they're very economical to use. The technology has advanced so much that most of these don't need any mesh at all in the field. You'll use mesh in the corners where you have a gap of 1/8 inch or more. You'll use mesh around the flanges of the drain just for strength in those areas. But you don't need mesh in the field of these applications, whether it's the floor or the wall. So that's why we kind of put it in the presentation here to take a look at these. They're very economical to use. And again, you have the dual purpose. Now, the one thing about the dual purpose, there are products on the market that are just waterproofers. So be aware when you're specifying, ask your tile installation products professional for the product that you want. And if the product you're specifying is both, is it a crack isolation as well as a waterproofing, or is it just a waterproofing product? Something I don't have a slide on here. So these are the liquid applied, but something I don't have a slide on here is there is also sheet goods, products that you roll out that are crack isolation membranes. And you could use them underneath the tile installation as well. They'll bond to the substrate in different ways. Some use primers and some don't. And again, they roll out on the floor. There's also waterproofing products that are installed more like a wallpaper. Just think of that concept of wallpaper. So you would put some mortar on the wall, you would apply the waterproof paper to it, and then you would seal the seams and put the next piece on. There's products around the market as well. Just be aware of those as well. So we take a look at our first drawing here out of the Tile Council of North America, the TCNA book we looked at on the left side in the beginning. So this is a typical drawing we would see in that, and I chose this drawing because it happens to include a crack isolation membrane. If you see the second row of wording, you'll see full coverage, and to the right of that, you'll see TCNA method F125A-full-19. So what that means is that this is method 125, and F stands for floor, and that's how TCNA will call out their drawing. So F will be for floor, W will be for wall, RH is for radiant heat, and so on. So F125 is the floor 125 drawing. A is for above grade, so this is suitable for above grade. Full is full crack isolation membrane. There's also an F125A partial. It's a partial crack isolation membrane drawing. And the -19 is the year of the drawing. So I want to suggest to designers and architects, when you call out your installation method, always make sure you include that year of the drawing. I see lots of brand new blueprints coming out with -15 and -14 on them. And that's going to be an old standard. You always want to call out the most current standard if you can. So we take a look at the drawing themselves. It calls out the products: ceramic tile, grout, Portland cement mortar, and you can see a crack isolation in there. And you'll see an asterisk on that. And down bottom, the asterisk is consult your manufacturer for membrane width. Different manufacturers are installed at different widths. They have different guidelines for installing. And of course, the TCNA is not about any one manufacturer. This is about installation methods that work, that are proven in the industry. You'll also see that the soft joints called out in this situation. Now they see a crack in the concrete, and that's why they called us out for the TCNA full coverage for crack isolation. It's used in this situation. You'll also see lots of drawings in TCNA where there's not a membrane included, but if you look in the body of the wording of the drawing, there's a lot of paragraphs that come after the drawing. We're going to talk about that. You'll see membrane options. So you don't necessarily have to call out a drawing with a membrane. You can call out a drawing that fits your situation better and then add the membrane to it. And some of the categories that come underneath this drawing in the TCNA, of course, the drawing, and then recommended uses. So you'll get a list of recommended areas where this installation may be suitable. You'll get a service rating. Is it light commercial? Is it residential? Or is it, heavy commercial installation standard? Environmental classification. So environmental classification in TCNA is about whether it's a dry installation, whether it's a sort of wet, sometimes wet, whether it's a saturated installation. And in residential, you'll have an R1, R2, R3 that covers those categories. In commercial, you have a COM1, COM2, COM3, and so on that cover those, wet, dry, completely wet. And when you look at these drawings and you say, well, I have a shower. So is this method suitable for a shower? You look down at the environmental classification and you can tell right away whether it's a residential or commercial installation, whether it's suitable for that. Typical weight of the installation, it'll give you a rough estimate of what that typical installation weighs. And they have a bunch of constant standards like the size of the tile or the thickness of the tile that they're figuring, the thickness of the mortar they're figuring if there's a mortar bed, just to help with that. Typical construction, what is it? Is it the studs? Is it concrete? Are we talking about sheathing, plywood? Limitations, some things to be aware of when designing with this particular method. That some situations you don't want to walk into with this method, maybe you want to look at a different one. And of course, as I mentioned, the membrane options. So you'll have a drawing with the membrane option of a waterproofer or a crack isolation membrane. And these are the categories that come along with this picture in an installation method in the TCNA catalog. And of course, there's installations over concrete, over wood, pretty much everything that you can imagine. And we talk about the mortar. So what changes with the mortar when we talk about large format tile? We had a term that was bouncing around and we were using originally when we created new mortars for large format tile, and that was a medium bed mortar. And that was effective, but I even got a lot of questions on the medium bed mortar terminology. A lot of design firms believe that meant create a mud bed. We need to create a mud bed to put in large format tile. And that wasn't the case. Medium bed mortar had referred to a different type of bonding mortar. The mortar that you use to bond the tile to the substrate. It was a bonding mortar that was able to go in deeper, right, which is required for large format tile, and I'll talk about that in a second. But that medium bed mortar term was confusing, so they changed it. They changed it to dry set mortar for large and heavy tile, which is referred to commonly in the industry as an LHT mortar. So summing all this up, when you have a large format tile, 15 inches or larger, you want to call for an LHT mortar or use an LHT mortar, large and heavy tile mortar. So again, below that, we have the paragraph that says you're not supposed to true the surface up with these mortars. You're supposed to use a patching material, as I mentioned before. But these mortars are able to go in thicker. And why is that important? Well, as the tile becomes larger, it's more difficult to avoid lippage. That is, lippage means one tile is higher than the next. You need those tiles to be even with each other to avoid a lip of one tile sticking up higher than the other, causing all kinds of problems, tripping, damage to the tile. In order to do that with a large format tile, traditional thin set mortar could not go in deep enough. You can see on the drawing here, on the slide in orange, 3/32 to 1/4 of an inch deep with traditional thin set. That just wasn't enough for a large format tile. So what was happening is tile installers in the beginning were taking that traditional thin set and they were putting it in thicker, deeper, to accommodate for the lippage, to be able to push that tile down. And what would happen with that mortar is it was not designed, it was not engineered to go in that thick. So it was slumping away from the tile overnight, among other things. The one to think of is it was slumping away from the tile overnight. And as it slumps away from the tile, it debonds from the tile. And obviously that was not suitable. So the industry has created, and it's across all the manufacturers, an LHT mortar. That mortar can be installed up to 3/4 of an inch before you push the tile into it. And that allows for the movement of the tile to avoid the lippage and to get the proper bonding on the back of the tile. Thickness are embedded thicknesses above, as I said, 3/4 of an inch, and then you set the tile into it. So the industry needs to use the LHT mortar for large format tile. The good news is, if you look at the LHT mortar on the bottom line of orange, you'll see that it goes in as thin as a traditional thin set. So you really only need one mortar on the job site. The LHT mortar will do it all. You don't need a traditional thin set and an LHT on the job. If you're putting in 4x4, 8x8, or a mosaic, you can use the LHT mortar for both installations. Also, mortar bed installations. You can use a traditional mud bed and a wet set mud bed if you want as well to install a large format tile, which is in the ANSI 108.1 A, B, and C, depending on your situation. Now, bonding mortars in ANSI are categorized by different performance characteristics. And the one that comes up quite a bit is with the architectural community is shear bond. So if you're talking about installation and bonding characteristics, the ANSI 118.1 at the top of the list here is a traditional Portland cement mortar. It's unmodified. It doesn't have the acrylic content, which pushes up the bond strength. So a 118.1 dry set Portland cement mortar, thin set rather, Portland cement mortar is going to be unmodified. And there are situations where maybe that would be called for. But TCNA is very clear about calling for a modified Portland cement mortar for the installation of porcelain tile, which is probably 75 to 80% of the tile being installed as porcelain. So they call for a 118.4, which was the old standard for modified Portland cement mortar, and it's still the current standard. It was the original modified mortar standard. And you can see there that it's a crack prevention mortar on the market for that. There, you can use it for walls and floors. They have a rapid setting version of that mortar, 118.4. And they make LHT mortars in 118.4. The question I get a lot, and I'm obviously may get some questions afterwards on this, is that ANSI does not make a mortar specifically called for large format tile. ANSI does not have a standard for LHT mortar. ANSI only has the standards for the bond strengths and performance characteristics of mortar. And you can buy the bond strength and characteristic in different mortars in an LHT version, is what I'm getting at. I hope that's clear. Maybe I can clarify that at the end if anybody has any questions. I may have been a little confusing on that. So LHT mortar can come in different bond strengths. 118.4 was the standard bond strength. The thing that I get asked about is the shear bond strength on that. And that was 200 PSI shear bond strength, a 118.4 modified mortar. Well, the industry saw a need for a stronger mortar. And the 118.15 standard was created. The shear bond strength on a 118.15 mortar is 400 PSI, double the 118.4 shear bond strength. And 118.15 is used quite a bit above grade, especially when a crack isolation membrane is not used above grade. Stairs, pools, anywhere where you're expecting more stress on that tile. And as the large format tile have become bigger and bigger, there is larger amounts of stress on each individual panel. So we're seeing the 118.15 specified and used quite a bit more. Because again, this is a AIA presentation. I also want to cover all the bases. A 118.11 is a latex mortar for thin set over plywood. All right, it's not recommended for natural stone installation, and every manufacturer has this product as well. It's not as talked about because with plywood we have residential situations mostly, but there is a product for thin set plywood, and it is the ANSI 118.11. So when we talk about core coverage on the back of tile, this is as critical as the mortar you use. ANSI 108.5 will call for no less than 80% uniform contact on the back of a tile. So when you're putting your mortar down, you're combing it onto the floor and then setting your tile in it. They're looking for 80% minimum uniform contact. You can see the tile below that didn't meet that standard. In fact, the substrate was obviously dirty because the mortar pulled off with it, but it didn't meet the 80% before we got there. Now 80% is dry. On the left, you'll see no less than 95% in showers or wet areas and exterior. 80% interior, 95% wet and exterior. The tile above the 95%, well, that's close. That's close to 95%, but we can see on the left side, there's a vulnerable part of the tile, the edge exposed. And that's something we want to avoid, cracking and chipping down the road. Also, on the 95%, that's for all stone. Stone is 95% as well. They don't have the 80% standard in dry for stone. For stone tile, it's wet, dry, inside, outside, 95% coverage. Now 95% is kind of random. I actually asked this question myself. Why didn't we just ask for 100? Well, 100 is very, very difficult to get. So if we can get 100, that'd be terrific. But the standard is 95. How do we get the 95? Is for large format tile, we want a back butter. And the picture you see right now is exactly what back buttering is. They'll take a thin layer of the mortar being used, and they'll press that into the back of the tile. This way, when you have the tile being pressed into the combed mortar on the floor, which you can see in the bottom left of this picture, it's ready to be pressed in. You'll have those combs expanding onto the mortar that's already grabbing the back of the tile. And this will give us our 95% needed coverage. Of course, the tile installer are supposed to, every once in a while, audit themselves. Pull up a tile, take a look, make sure you're getting the proper coverage. But this is the way to do it. Now, this is incredibly good coverage, right? This is 100% coverage. And we'd love to see this on all installations. Okay, our world of expansion joints. So in TCNA, there are 10 pages called EJ 171, and it's the recommended soft joints, expansion joints, control joints. In there, we have soft joints in place of the grout joint every 20 to 25 feet interior. So every 20 to 25 feet north, south, east, west, we would want to use a soft material, silicone, 100% silicone in that joint. Every 8 to 12 feet exterior. So 20 to 25 interior, 8 to 12 exterior. We need to include a perimeter joint. We don't want to butt that tile up against anything. It's going to restrict the movement, obviously. So we need a perimeter joint wherever the tile is installed. We need a soft joint at change of plane. So inside, outside corners, floor to wall, that's a change of plane, and we're going to need a soft joint there. Add a termination or stop. Well, that's very similar to the perimeter joint, right? Wherever the tile butts up against something, we don't want to butt it directly to it. We need a joint there to allow for movement. And engineered joints in the subfloors and walls. This is huge. If your substrate, whether it be a concrete floor or a wall, has an engineered joint, in other words, a joint that's there because the two products are meant to move, the two slabs or walls are meant to move independently, even if a little. You need to honor that joint directly up through the tile. Okay, I have a picture of this coming up if I'm not explaining it well. Special case interior. If you have an interior that has a lot of thermal stress, possibly skylights, atriums, lobbies, then use the exterior standard of 8 to 12 feet for a soft joint, north and south, east and west, as I said, instead of the interior 20 to 25. A lot of times in malls, we'll see lots of skylights and a lot of natural lighting come in, and you'll see they put more expansion joints or control joints in there for the, or soft joints rather, for the tile. And here's a picture of that slab I was talking about. This is a through joint through the slab. It's meant to move at that point, and it could move not only side to side, but it could move very little up and down. So that soft joint is completely necessary right over top of that joint in that slab. And this is a picture taken right out of TCNA's EJ 171. You see the sealant, the backer rod, which holds the sealant up. And I think I probably have yeah, there I have the other pictures. So EJ 171, I said, is 10 pages, but here's some other examples of the type of drawings you'll see in there, and this is how useful this is. If you're writing a specification, I certainly would suggest including referencing EJ 171. If you're an installer contractor, certainly become familiar with these standards. They're critical, and as I said before, I'm told it's the #1 reason that tile installations fail is the lack of these proper joints. We could take a look at these individually, but like I say, there's 10 pages, and I don't want to miss anything in particular. Just be aware that that's there, and this is something I can talk with you about more afterwards or even separately. Okay, so for installations of large format tile, what does the specification include and what does it need to include? So utilizing an LHT, as I mentioned. Now, if you're looking at your specification as an installer, if it doesn't call for an LHT mortar and you know the tile is larger than 15 inches, you know that you're going to be beholden to use that LHT. It's the proper product to use. If you're a specifier or architect, I would suggest language that includes the utilization of an LHT mortar for any tile over 15 inches. Dynamic coefficient of friction. This is something that changed quite a long time ago now, but I still see the old standard. The coefficient of friction is the slip, we'll call it the slip and fall. So how wet is that substrate, not the substrate, but the finished flooring after it possibly is wet. The dynamic coefficient of friction should be listed in the specification and be aware of. The reason why is because if a tile is substituted, you want to make sure it meets this standard. I've seen instances in the past where the tile will be substituted because it looks identical or close enough to the tile that was specified, but the tile that was specified met the dynamic coefficient of friction for slip and fall, whereas the submitted tile did not. So if you call this out in your specifications, the contractors are aware of what they need to provide and do. Verify that the joints and the substrates are coordinated with the tile joint location. Again, some joints cannot be moved. You see the one in the concrete, it can't be moved. So when designing, as hard as it is, you need to take that into account when you're designing your pattern in the floor. Single source manufacturer. I say go with a single source manufacturer at all times so you keep that warranty. If you have a warranty on a product, it's kind of a 1-year or a 5-year warranty if you use different manufacturers. If you go with one manufacturer, it could be 15, 25, depending on the products used, and it's free. There's no additional charge for that. When listing multiple prep products, installation products and prep products, list the manufacturers in each category so they can do the single manufacturer source liability clause. They can get that single source warranty if you list the manufacturer in each category, instead of cherry picking different manufacturers in different categories. And then, as I said, the LHT mortar. Okay, what could possibly go wrong? Lippage, as I mentioned before, this is dangerous on a couple of levels. It's obviously, it's a trip and fall, but it will also damage that tile, and the tile can continue to degrade after initial damage. So this is what lippage is. Unfortunately, we've probably all seen it out in the world. This is kind of critical lighting, but it still is lippage. With rectangle tiles, because of the situation of doming, where one tile maybe in the middle is domed up a little bit with these longer tile, the industry has come up with a remedy. If the tile is larger than 18 inches, go with a 33% overlap opposed to a 50% overlap. Again, this is a suggestion in ANSI. Some designers don't go this way. Just be aware that you may have some tile that's culled out because of that, the tile that's unusable. And you see here just some areas where the crack is there for a reason. It's a shame. Something wasn't done in prep. Something wasn't recognized in the installation. This is an extreme case. I see many of these in much more subtle cracks and whatnot, but this is where the mortar was not placed underneath the tile, or maybe shrunk away from the tile, and then a lift or something was driven over this, because like I say, it's pretty extreme. But I see cracks in corners of tile quite a bit, or on edges of tile, where maybe that is more subtle, but it disintegrates the grout and deteriorates over time. So this is, like I say, it's the type of thing that can happen. You see a crack right across the tile. If you have concrete moving underneath, the tile and the mortar are really no match for it. In this instance here, if you look at the picture on the left, there is a soft joint they installed about where the number 4 is on the tape measure. Well, unfortunately, the joint was where the number 14 is in the concrete, but it didn't match up with the joint in the tile. I understand this is an issue, but you have to honor that joint directly above, because this is the kind of thing that will happen. The picture on the right is the same picture, just from a higher above. It looks like a different color, it's just a shading. But like I say, unfortunately, that joint really needs to be honored directly through the tile when there's a joint in the concrete like that. This is called tenting, right? No soft perimeter joints. Tile has nowhere to go when it expands, so it's going to go up. A little closer look at what tenting looks like. They call it a cute name, but it's not cute, right? The around the area that's dissimilar, you have the metal, you have the tile. You're going to need a soft joint in this area, and you can see that the ramifications of not putting that soft joint in. Not only did the grout get destroyed here, it started to disintegrate the tile because the edges are exposed. So again, soft joints around the perimeter of any tile installation are critical. Speaking of joints, we'll talk about the grout joints here. So what is the difference between a grout joint in a traditional installation and a large format? Well, traditional installation, you can go down to a 1/16 of an inch, or 3 times the facial variance of the tile, right? That used to be on the box more. The facial variation on the tile used to be on the box. It's not on there so much, so the 1/16 of an inch kind of kicks in there. 15 inches or larger tile, they recommend a minimum of an 1/8. Okay, and if it's not a rectified tile, then 3/16 on that tile. If it's just a calibrated, rectified or machined, so the tiles are all about the same size, width, length. Calibrated is more of a measured tile rather than machined. They're not as exact, so they recommend a larger joint, 3/16, opposed to the 1/8. Okay, so if we recap, TCNA changes. 15 inches is the cutoff there for a large format tile. Things change at that point, we talked about. Surface prep becomes more critical. Remember, it's an 1/8 in 10 for large format tile. Always use an LHT mortar. Large format tile should be back buttered so we can get that proper 95% coverage on the back of it. Specify a 1/18 tel crack isolation membrane. Always include single source. All right, single source is going to get you that literally free warranty from the setting materials manufacturer. We all have them, whatever your choice of setting materials. If you list all the products, or if you're a contractor, if you use all the products from that company, you're going to receive a longer warranty for your client, and it's free just for using all those products. And of course, TCNA EJ171, critical for tile installations. That's all your soft placements of joints and movement joints. Okay, Jim, I think we're at the end.
Andy, fantastic presentation. I'm sure the audience really appreciate your expertise and knowledge. Extremely informative, and some great cautions and best practices. If everybody will please, before you leave, just look at your chat screen or your question area. I have a couple of times put down Andrew's email address for the AIA CEU. I've also put down my email address if you'd like to get the archive version. Please look at that. Now, Andy, we do have some questions, so let's start.
Great.
The first one is, what is the movement capabilities of an uncoupling membrane or an anti-fracture membrane?
Well, obviously depending on the manufacturer, of course, but if you have an uncoupling membrane, the way they're used opposed to an anti-fracture is uncoupling membrane will do exactly that. It starts out bonded to the substrate, but it will uncouple or release from the substrate. Whereas an anti-fracture or crack isolation membrane, again, with those, we're talking about the ANSI 11812 standard, and they have to be able to move up to an 1/8 of an inch. But different manufacturers have different standards for their uncoupling membrane as far as movement, but they're actually not used in the same way. And I get this question. I know that's not what was asked, but I just want to share. The crack isolation membrane is used in where you have an area where the substrate is bondable, and uncoupling membrane is used where the bondability of the substrate and the movement of the substrate is in question. So you got to look at each individual manufacturer to look at how much movement the uncoupling membrane can handle. The crack isolation membrane, if it's a 118/12 from ANSI, it's an 1/8 of an inch.
Great.
Great question.
So next question. In regards to expansion joints over a heated floor assembly, are they the same requirements, 20 to 25 feet interior, 10 feet exterior?
Yes, I mean, like I say, you could always use the 8 to 12 interior, which is the safer bet if you're expecting a lot of movement, thermal movement, whether it's from the sun or it's the heat. But yeah, there's not a change in it. The EJ171 is the same application that applies for the radiant heat, the RH drawings.
Okay, great. All right, here's another. If silicone is used to fill 2 adjacent soft joints as required by F125 and crack isolation manufacturers, must one use a bond breaker tape or a rounded backing rod under the sealant to prevent 3-sided adhesion?
I'm not sure I understand. I'm sorry. I will say this: you always want to avoid 3-sided adhesion. So you're the question asker is 100% right about that. But adjacent to each other, were they maybe at a cross section?
Yeah, I'm not clear on it either, Andy. I will tell you that in the NTCA workshops, we always recommend using backer rod under it for that exact reason, not to get 3-sided adhesion. So
yeah, that's probably the best thing to come out of that. It was a great question because we could talk about that. That's very important to avoid that 3-sided adhesion.
All right, here's another one. Let's see. This person says, I keep seeing instances of expansion joints that are filled with grout, often with as little as a 16th inch joint, rather than proper sealants. Any thoughts on why this is still so prevalent in the industry?
You know, it's a great question. Like I say, the #1 reason for failure is the lack of those joints. I think maybe, I had to say it's a lack of knowledge in the industry, because certainly folks like yourself and ourselves, we're always promoting that. So I don't know why it's left out. It's just maybe lack of awareness that it needs to be there, but it certainly does need to be there.
Your last sentence there was the most important, and we see this all across the country in the workshops we do, and we do 100+ workshops a year, every year, and a lot of it is contractors don't always know what they don't know, and the education's out there for their finding and for us to provide for them, but they don't always get it or take that information into consideration when they're doing a job. So it's the information's there for them, and we just hope we can continue to educate and get to more and more contractors and alleviate this problem.
Absolutely.
All right, let's see here. So someone said, thank you, great presentation. Let's see what's next here. What was or is the ANSI spec for lippage?
ANSI has a specification, or for a guideline for acceptable lippage. I don't have it open in front of me right here because it's going to depend on the size of the tile and the size of the joint, and then they have a chart you refer to. I could get the page in ANSI that does offer that information. It is a guideline though. It's something for a designer or an architect or an installer to hang the hat on if it comes into question whether what they did or what they have is acceptable. So ANSI offers those standards for that reason. And again, I can get that page and that information over to whoever needs that. And they do have that chart in the catalog.
So if you would like Andy to answer that, which he certainly can, please don't hesitate to email him at the email address that I have put on your chat screen. That'd be great. You can also call Custom Buildings Products Custom, their technical line, and I'm sure they can answer it for you also, or the NTCA. Please give us a call. All right, here we got one. Are there any suggestions to repair cracks other than just using membranes?
Well, yes. I mean, there are cracks and then there are cracks. We have to take a look at that crack and make sure that that movement is in plane, meaning side to side again. If you have a crack that is moving out of plane, which would mean that one side or the other is either lifting or dropping, that's going to be a faulty slab and that needs to be repaired in a different way. So we have crack isolation membranes to handle that side to side movement, and again, up to 1/8 of an inch. But if it's a crack that's not moving in plane, then that's going to have to be repaired in a different way, where they're going to have to cut out and they're going to have to fit and dowel a new piece in and pour some more concrete to fix that situation there. You have another way, as another question had asked about the uncoupling membrane. So if you have a slab that's moving quite a bit in multiple areas and you're not really sure about that installation and whether that's going to bond or continue to move, you can use an uncoupling membrane, which is going to allow that floor to float if that substrate moves too much for it. It's going to debond and allow that floor to float quite a bit. And then on top of that, if you have room for a mud bed, you can use what TCNA refers to as an F111, which is a cleavage membrane. It's plastic or tar paper down, and then a mud bed, which keeps that mud bed from bonding to the concrete. That moving, unstable concrete, it'll keep that mud bed from bonding to that and allow that floor to effectively float as well. So you have a couple of tools in the bag depending on how bad your floor is and what you need as far as insulation and usage. But the cracks themselves, it's going to depend on what they're doing and how many there are as far as the the installation standard you would follow.
Great. All right, we have another question, and it has to do with using a vibrator to embed a piece of tile or pieces of tile. And I know it's recommended for gauge porcelain tile panels and large panels, but how do you feel about it for just regular tile, large format tile, 12 by 24, something like that?
Okay, yeah. Well, in all the training seminars I watch that our folks put on, it's really a push and smush technique. Literally, that's what they call it, creating your coned lines and then pushing the tile against them, side to side across them, to spread those ribbons of mortar. I'm not familiar with that being necessary. It's the vibrator being necessary with the tile that you can do that with. The vibrator and the compactor there, so to speak, is really because large panels cannot be pushed and smushed. They're just too large, too many people. It's impossible to do. But any tile that you can set, whether it be a 36 or 24, and then you can literally slide that tile, push and smush it back across the ribbons of mortar, allowing them to spread on the back of the tile. I would imagine our technical trainers would suggest that that's the method you use if possible.
Great. So this answers for Paul Costanzo. Yes, this webinar is available, archive version to review later. I did put my email address on the chat screen, but please send your request to jim@tile-assn.com. Let's see what we have next. Let's see. He's okay. So back to asking about adjacent soft joints. And he said on the F125 slide, it shows a soft joint on either side of a tile covering a crack.
Well, there's either side of a tile that spans the crack, as I think. Right. Okay.
So, correct.
Right. Okay. I just did for my own, so I understood it. Okay. So there are ways of doing that where you have a crack and you have an F125 where you can put an expansion joint on each side of the tile that does span that crack. And that's acceptable in certain instances. It's really going to depend on the crack. If the crack is not expected to move beyond, like I say, that 1/8 of an inch, then you can go ahead and do that, as it points out in TCNA. If you're expecting a lot of movement out of that joint, then I would suggest that crack, I would expect the joint should really be right over top of that crack. That's not always possible. Lightning cracks move side to side and they go all over the place. So hopefully that crack that's moving side to side and going crossways, so you cannot put a joint right over it, is not moving so much that soft joint on either side of that spanning tile is not going to be able to handle that movement. So it really depends on the crack and your situation. And here's what I would suggest, and this is not a cop-out in any way, but we have all these folks out in the field. Depending on the manufacturer that you're working with, setting materials manufacturer, we have people out in the field to go and look at your situation, see what you have, and offer you some professional advice on what to do there. So I would always suggest that if you're wondering about that, not that they're saying they're wondering, but if they get in a situation where not really sure which method to go to, have someone come out, professional, again, whatever material manufacturer you're working with, and give you a recommendation on that slab. It's going to be the best way to ensure your success of your project, and you'll get it in writing. So that's my suggestion.
And if this had to do with should you use backer rod in there, yes, you should use backer rod in both of those. So
Right.
Just want to be clear,
Yes.
you should always use a backer rod.
Yes, yeah.
All right, here we go. Let's see. So this one is an FYI for us. The F125 question was asking about crack isolation and the need to install a soft joint on either side. All right, you just answered this, so that's great. Good job. Let's see here. What's this one? According to the handbook, isn't the maximum thickness of LHT, large heavy tile mortar, after the tile is embedded at 1/2 inch rather than 3/4 inch?
Yeah, it's 3/4 inch before it's embedded.
Maximum
So it can go in.
before bidding.
Yeah, it can go in up to 3/4 of an inch.
Perfect.
It's not always necessary to go in at 3/4, but it can go in up to 3/4 inch before embedding.
And once it's installed, it should not be more than 1/2 inch, correct?
Be down to 1/2 inch, yes.
Yeah,
that gentleman or lady or gentleman, which one it was is exactly
all
right.
right. We have, it was a gentleman, and we have many thank yous and a good presentation. We have one last question, and that will be the end here. So here we go. Sometimes this person does large format tile, and the designer or homeowner wants a 1/16 of an inch joint in the tile, and it's not rectified. Do we deviate from the 1/8 inch? How do you handle that situation, I think is what they're asking.
Right. Well, what I always do, and I have designers who say the same thing to me all the time or ask the same question. And my answer to that is that this is what TCNA recommends. This is their suggestion for successful tile installation. But if the design is going to override that, in other words, the ownership or the designer decides, well, that's not the look I want to go this way, they certainly can do that. Absolutely. There may be a ramification for that decision, and like all decisions, they may find out that they have a little bit of grout cracking. There wasn't just enough movement in that 16th. It should have been an 1/8. But all those situations, or it may be absolutely fine. They may never have a situation that comes up and causes a problem because of that. So,
Andrew, would you ask them to sign off on that? Show them a copy of it and just say, please sign off on this, that we are moving away from methods and standards of our industry.
That's a great point and a statement, Jim. I'm going to remember to say that again because that's the right answer. TCNA recommends it one way. If you want to do it another way, certainly it's your prerogative, but I would have them sign off on it. Make them aware that TCNA recommends it this way. You're kind of at your own peril if you do it differently.
And my reason for saying that is, from the contractor's point of view, is the contractor is supposed to be the expert. And if you put it in and don't get it signed off and there's problems, you're probably responsible to come and fix that grout line and repair it. So
that's exactly
always,
right.
Always think about, you do it by the methods and standards of our industry. And if you do it that way, it's correct. And if you decide not to do it because of architect or homeowner requesting, at least get them to sign off on it and make note of it that you're just following their guidelines. It may not help you in the long run, but it's way better than just doing it. So
right, absolutely. Yep.
All right, everybody. Thank you. I think Andrew was fantastic. He gave a lot of good best practices, a lot of information. Please look forward to our next webinar. There'll be an invite coming out shortly. And Andrew, thank you again. Bye, everyone. I appreciate it.
Thank you.